calculate the partial of f with respect to x, the partial of f with respect to y, and the partial of f with respect to z for the function f of x, y, z equal to secant, parentheses, x squared times y, close parentheses, minus tangent, open parentheses, x cubed times y times z squared, close parentheses. In order to find each of these partials, it's going to be necessary to talk about what it means to find the partial with respect to x of something like x squared y. So let's walk through that. So the partial with respect to x of x squared y means that we're going to treat every variable that is not an x as a constant and factor it out as such. So this will be equal to y times the derivative of x squared, which would be equal to 2xy. Similarly, the partial with respect to y of x squared times y, for that we would treat the x squared as a constant. So this would be the x squared times the derivative with respect to y of y, which would be equal to x squared. And finding the partial of either of those with respect to z would be equal to 0, because then in that case x and y are both constants. All right, on a similar note, see what the partial with respect to x of x cubed times y times z squared would be. For that, we'd treat y and z squared as constant, so y times z squared multiplied by the derivative with respect to x of x cubed. And because the derivative with respect to x of x cubed is 3x squared, this would be 3x squared y z squared. All right, now we'll find the partial with respect to y of that same expression of x cubed times y times z squared. We'll treat x and z as constants. So this would be x cubed z squared multiplied by the derivative with respect to y of y. That's equal to 1. So that particular partial is x cubed z squared. And then finally, the partial with respect to z of x cubed times y times z squared. For that, we would treat x and y as constants, so we'd have x cubed y multiplied by the derivative with respect to z of z squared. That derivative would be 2z, so this partial with respect to z would be 2x cubed y z. Now we're going to apply the chain rule, okay, to our original function f of x, y, z, so that the partial with respect, or the partial of f with respect to x would be equal to secant of x squared y multiplied by tangent of x squared y multiplied by the partial with respect to x of x squared y, which we already determined is 2xy. So multiply 2xy. So the partial of f with respect to x is secant, parentheses, x squared times y, close parentheses, tangent, parentheses, x squared times y, close parentheses, multiplied by 2xy, minus the derivative of tangent is secant squared, so it'd be secant squared, open parentheses, x cubed times y times z squared, close parentheses, multiplied by 3x squared y z squared, using the previous partials that we have. All right, this makes the partial of f with respect to y equal to secant, open parentheses, x squared y close parentheses, times tangent, open parentheses, x squared y, close parentheses, multiplied by x squared minus secant squared, open parentheses, x cubed y z squared, close parentheses, multiplied by x cubed z squared. And finally, the partial of f with respect to z is equal to negative secant squared, open parentheses, x cubed y z squared, close parentheses, multiplied by two x cubed y z.